Assalamu alaikum. We are all welcome to this session. The session that I promised that I wanted to make a video on how to use the multi-syllable benchmark for performing experiment, especially for nonlinear equations. So we are going to use this multi-syllable benchmark, or we are going to test it on some benchmark. But before testing, I will open it in MATLAB and also explain some of the important facts of this code. So I've just opened it in MATLAB. I double click on it. So it opens MATLAB now, and it is in the folder. It's open it in the folder, that is in the directory where this code is saved. So this is the multi-syllable benchmark, which is coded, or which is developed for solving experiment, especially for nonlinear equations. So there are some lines which are very important here. But what this solver is doing is that it will first of all run multi-syllable. If you run it, you run it over problems, dimension, and initial guess. And it will give you output, that the Excel file, and also the Dolan-Moré performance profile for maybe the matrix that you have chosen. In default, we have used 3 matrices here, but it depends on which matrix you want to plot the Dolan-Moré performance profile. So you just choose them because they are available. Now, when we look at this, the code in line 7, that is where we normally get our file, the output of our file, Excel file. So this line 7, maybe let me see if I can increase so that it will be clear. It will come clear to each and everyone that is watching this video. So you see line 7 is just where we normally write the name of the Excel file. This is just a default. You can change the name of the Excel file, but what is important is adding .xlsx at the end to let MATLAB know that you are opening, or you are opening an Excel file. So for example, now if I change this 2 to 3, it will open different Excel file with name result 3 instead of 2, because 2 is already there. I use it. Maybe if I scroll down, you see result 2 is there. I've already used it. So maybe if I want to do another experiment, then I have to change the Excel file, maybe to do it in another Excel file. So this is very important, line 7. And now also the next lines are also very important, because that is where the solvers are defined. So you name each of your solver. Each solver must be callable as in this form. So this is very important, this line 10. Even though it's a comment, but it's a comment that is very important. If you are going to write the code for your solvers, you have to write them in this form, meaning that the solver name is here, which is solver, and then its input must be the function value, and then the initial point x0. So then the output should be in this form. The last point, that is at the iterate, and then the information, which when we come to solver, you see what is this information is meaning. So after that, you can write the name of your solvers here by this command, solvers is equals to. Make sure whatever name of the solver you have, you start with at. The name should start with at. Then you separate them by comma. Even if you have 100 solvers, you can put them here. So you put all your solvers here. separated by commas, and each solver must start with at. Take note of that. And then there is solver name. This is the name where you want to call your solver. It depends. Maybe in your graphs, in your tables and your graphs, maybe you want to call your solver or your solvers different names. So it depends. If they are the same, then the name that is here is supposed to be the same thing with the name that is in line 12, supposed to be the same thing in line 11, but not necessary. But the way you write 12 is different from 11, because 12 is a string. So you put this, what do you call them? This, you put the name of the solver in between these strings. But this, the ones that is in line 11 is the main solver. So there is no need for string. So it's like the function. Now, another lines that are very important for the experiment are the dimension, guesses, initial guess, and the functions. So maybe you are using 10 dimension or 5 dimension, you just put them. Maybe if it is 10, you put 1 to 10. If it is 2, for this one, it's just 2 dimension. I think I leave it for just checking or for test. And then for guess also, if you have 5 or 10 or 20, depends on which initial guess, how many initial guess you get, you just put. If you have 10, you put 1 to 10. If there are 5, you put 1 to 5. Here we are going to test 2, only 2 initial guesses. And then the function list, just like syllabus, each function must start with at, with the name of the function. The way you save it in your MATLAB. You see, I saved all those functions in the name of NS, NEQS, NEQS1, NEQS2, and so on. So that is how I list my function in this directory. You may have your own list, different from mine. It's not necessary that. It depends on how you put it. And then there is function names, which the name of the function that you want to maybe call your function or identify your function in your tables and your graphs. So that these are the ones, or this is the place where we normally put. If you put 3 functions here, then you must have 3 string name of function here, and so on. So the next 3 lines are also very important, because it's the where we pre-allocate result table. Because in our Excel table, there must be some columns. Those columns are where we put our result. Maybe we start with the solver, the name of the solver, then the problem, then dimension, then number of iteration, then number of function evaluation, then number of backtracks possibly, and then number of the CPU time, and then the final residual. So each of them we have to define them here as a result, but some of them are string. For example, solver is a string, problem is a string, but the rest, dimension, iteration, function evaluation, all of them are double up to the end. So there are 8 entries here. You may have more than 8 entries. Yeah, so that is the size. You may have less than 8 entries. It depends on how you are going to, how you set your experiment. So you can change it. As you see, this is just an editable file. You can change it the way you want it. The only thing is that to understand what it's doing, that's what is important. So from line 25 up to line 70, that is where the work is. That is where we have the for loop. We have about how many loops? 4 loops, for loops, which the first for loop is for the solver, the second one is for the dimension, the third one is for the initial guesses, and the fourth one is for the functions. So this is where the work is done. And in this loop, inside this loop, that is where solvers are called. We call the solver in line 40, I think. We call each solver with this command. So you see, we call the solver like this, with this handle, function handle, and initial point handle also. Then we put the output as SK as input. So each solver will come and enter this line 40. We process it, we get the result, and then we put the result in the output, which is XK and info. So if, for example, there is a failure or whatever, then we put not a number. Just as you can see, we have some lines that also give that. But if there is none, then we give the result. Elapse, which is the elapse, the time, the CPU time, we put it in double. ITER also, function evaluation, number of backtracking, and final residual. So at the end of the day, we serve the result, all the result in this using write table result output file. You see where our output file come, because we already named our output file. So since from the beginning, remember, so this is where it comes, because we write the result on it. And then we end. Now, that is the end. Then after this, from line 76, or from line 1 up to line 76, that is the result or the experiment, and then we save the experiment in Excel file. Down will be a preparation for obtaining or for creating or for generating the graphs. That is the Dolan-Moré performance profile. So this is just a preparation. All this line, we have this. Then these are the lines where we normally compute the log 2. So also we create a folder to save the graphs after generating them. So the name of the folder is benchmark figures. You can see the folder here at the top. Look at it, benchmark figures. So it's the folder that we use to save all the graphs. And then these are the code. This is the for loop that generate the graph for us. So, and then there are also some important lines. This is where we level the x-axis and y-axis. This is tau, you see, and then phi of tau. And this is where we normally put the performance profile, that is the name of the figure and whatever. This is the legend. And then this is where we put the name of or the kind of figures that we want. For example, we want to output PNG file, so we need .png. We want to output .pig file, which is the MATLAB file also. We want to output the EPS file, which we can use in our LaTeX. So these are the things. Okay, then we can also save them. We have to save the EPS, just like we save the PNG and pig. Maybe that's what I forget to enter here. So EPS. So that's it. Then at the end of the day, we close everything and we get the result. Then the rest lines are where we define the functions for dimension and initial point. So if you have 5 dimensions, for this one as a default, we have 5 dimensions. If you have more than 5 dimensions, you can add. There's no problem. You can add the cases. And if you have less than that, you can remove those that you don't have. You can edit this with the ones, the dimension you want or you want to use in your experiment. Also here, that these are the cases, the initial points, where we have 10 here with this. So if you have different, you can change. If you have more than 10, you can add. If you have less than 10, you can reduce the cases and put the ones you have. So everything is editable. You can edit it. So that is the end of the description or a simple explanation on this benchmark or multi-syllable benchmark. The next thing is to test it. So for testing, make sure that your syllabus are saved also, or your benchmark multi-syllable is saved in the directory where your syllabus are. I have 2 syllabus here, DPRP plus and hybrid plus. So I want to test them. I have already put the names of them. You see them. I changed the name of the Excel file to result 3 because I've already used 2. And then also I put my function list, NESQS1, NCSQ, and maybe 3 functions for test. That is it. Then this is the only things that I need to set, or these are what I'm supposed to add. These are the only maybe lines I need to change in my experiment. So if you want to make an experiment, these are the necessary lines that you need to change. Then, but there are some other lines maybe you want to change also, especially in the case of what you want to be the output. But before that, the main important thing is in the graph. That is which kind of graph you want. You can change to depends. And also the lastly, I think you can change the dimension and initial guess also. So you have to make sure you make all these necessary changes before you start your experiment. Now, before we start our experiment, let's first of all check our syllabus. We say each syllabus must be in this form. That is, the input must be f and x naught, and the output must be x and info. And we don't know what is this info. So when we open a syllabus, we are going to see. Let's open either hybrid plus or DPRP plus, because they are the ones that we are going to use them here. So I have seen DPRP plus here. Look at it here. So let me open it. So I open DPRP plus. Look at the function. The first line, that is how we get the same form of what we are talking about in the benchmark or multi-syllabus benchmark. So you see, this is the output, and this is the name of the syllabus, where we put syllabus here. Instead of syllabus is the name of the syllabus, which is DPRP plus. And then the input should be our function handle and initial point handle also. So this is how you have to put your, or even if you have more than, if you have 100 syllabus, you have to put them in this form. The input must be f and x naught, and the output must be x and info. What is this? We know what is x cubed. This is the last iterate. But what is info? Let's go down and see what is info. So when you go down, at the end of the code, you will see what is info. The info are those iterations, function evaluation, number of occurrences, final num, and the elapsed time, which is the CPU time. So look at the form where, or the way we write them. So that is how you're supposed to write them also in your work. So info.iter, info.function. So all this information will be kept or will be stored in that variable info. So it contains all the information of the experiment. So after that, then I think this is clear. We have seen how our syllabus are. The next is just to run the experiment. So we just run it because we have already set everything. We want to test 2 dimensions and 2 initial guess, 3 function, and then so we just run our experiment. Let's run. You see the run here at the top. We just click on it. So let's see. It has started running. So already it has finished. You see my graphs have been coming out. It has already finished because there is not much problem. It's just 2 dimension, 2 initial guess, and 3 problems. All of them are here. Look at them. About 24 runs. So we can check the graph. We can check the table now. We can also check the graph. Let's check the table. I think the table is in result 3. Look at it. We can right click on it and open outside MATLAB to see the Excel file. So look at it. Look at it. DPRP plus. These are the result of DPRP plus. Dimension, iteration, function evaluation, number of backtracks, elapsed time, and residual num. The final residual num. And then this after line 13, line 14 to the rest, to the end, is hybrid plus. That is the result of hybrid plus. So if you like, you can just copy this or cut this and put them here to be side by side with the one of DPRP plus. And then you copy also this line and paste it here. So it depends. You just customize your Excel the way you want it. And if you have Copilot, you can ask the help of Copilot, which I have Copilot here. You can ask the help of Copilot to customize your your Excel file the way you want it, just by using commands. So Copilot is just like an AI assistant here. Now, so this is for the Excel file. Then we go and check the what do you call them? The graphs. So we come to the benchmark figures, because that is where our graphs are saved. We open them. You see, it gives us all the graph, the EPS file, the figure file, and the PNG file, the one we want to use. Any one you want to use, you can use it. It also, for each of the graph it's it gives us 3 of them. So I think we plot a graph for iteration, function evaluation, and CPU time. So there are 3. So if you want to check for iteration, for example, you open the pig file, which is for the MATLAB. Let me just open it. So you see it here. This is for MATLAB, because we don't have much problem. Even from here, we see which algorithm perform best, which is hybrid plus, as you can see. So this is the y-axis, this is the x-axis. This at the top, you see performance profile with respect to iteration. So if you take it, you go and put it in your LaTeX, you can put the caption at the bottom. So you can also check the one for function evaluation, you see it, and also check the one for CPU time. So all of them are there. Everything is there. So you just take it and put it in your LaTeX file. And feel free to update this MATLAB code. It depends. It's not, sometime you may want it to use to maybe to get another, or to plot another different graphs. So it depends on which graphs you want. But for this one, in default, or for as default, we just make it to plot the performance profile, the Dolan-Moré performance profiles, the one we are familiar with always. So, but you can plot some other graphs different from this one. And then also you can change the entire format of the code. It depends on what you want, and it depends on which kind of experiment you want. So if you have any question, you can send it to me through my social media account and whatever. Inshallah, I will try to see if I can help you with any problem, especially regarding the code. Thank you.